Hello, everyone. This is Lynn. I'm very excited to use YouTube channel to discuss kinematics in two-dimensional questions with you today. And first, let's talk about projectile motion, and then I'll discuss the velocity of a spacecraft problem that we see in Physics 111. And also, the last, I'll talk about multiple concept problems. For the projectile motion, we consider the horizontal and vertical parts of the motion separately. In the horizontal of x direction, the moving object does not slow down in the absence of air resistance, so the x component of the velocity remains the same. Vx always equals v naught x, and there's no acceleration in axial, the direction. In the vertical, however, the projectile experiences the effect of gravity. As a result, the y component of the velocity vy will have an acceleration 9.80 meters per second square. And here is an example. There's a spacecraft, and it has a Vx and Vy velocity. After you put the V into x axial and y axial, and here is a solution. Step 1, we need to find out the right formula and use Pythagorean and trigonometry to find the magnitude and direction of the velocity. The reasoning behind this problem is the vector and its components form a right triangle, the hypotenuse being the magnitude of the velocity and the components being the other two sides. Thus, we can find Vx and Vy. The final velocity will be explained begins through these two equations. So the conclusion will be, with the data given for the kinematic variables in the x and y direction, we could find the final speed. Like in this question, after 7.0 seconds, the spacecraft has a velocity of 210 meters per square in a direction of 27 degrees above the positive x-axial. Don't forget the direction of the velocity. Here's another example. Conceptual example 2. Suppose you're driving in a car. The car is moving to the right at a constant velocity. As you can see, you point a rifle straight upward and fire it in the absence of air resistance. So, how the bullet will land? Behind you, ahead of you, or in the barrel of the rifle? So, for this question, because there's no air resistance to slow down, the bullet experiences no horizontal acceleration. So Vx will be constant. So A and B are incorrect. The answer C is correct because if the Vx remain the same but in the y direction, the remain matches to y direction component would be greater than that of the rifle and the car. The remain matches to that of the rifle and the car. As a result, the bullet remains directly above the rifle at all times and would fall directly back into the barrel of the rifle. This solution is analogous to that where the car packaged. So, reasoning strategy will be first applying the equation of kinematic in two-dimensional. We make a drawing first and decide which direction not to be called positive and negative. The third step will be the time variable t has the same value for the part of motion along the x-axis and the part along the y-axis. Write down the value that are given for any of the 5 kinematic variables and then verify that the given information contain values of the at least 3 variables for the problem. When the motion is divided into segments in x-axis and y-axis, the final velocity for one segment is the initial velocity for the next segment. So kinematic problem may have 2 possible answers. Try to visualize the different physical situation and to pick the right answer. So this is my presentation, and I hope you can learn something from this presentation. Please bear me because this is my first time to do a presentation on YouTube. Thanks for watching.